Hello everybody and welcome back to another video. In today's video we are going to talk about static storage in C++. So why is this stuff important? To start with, C++, once there is a static array, needs to fill up that buffer space with all of your object blanks, which means it's going to call a destruct or a constructor each time, or not, or even if the constructor is inlined, it is going to try fill it out up one way or another. I verified this on every optimization level, including O1, O2, and O3. So it never really goes away. So for example, what are we talking about here? Let's say I have a static array of assets, or not even a static, but what I really mean by static is not really the static keyword, but something that's allocated on stack. So there is an S array that contains the number of arguments of 10. And we can see that it tries to fill it up anyway. So even if it's a static one, even if it's a global variable, in other words, or something we put in data segment, but with something like user-defined types, they don't necessarily go to a data statement segment like int or character buffer on stack would. So the importance of this is what if we have a million elements and we still have to reassign them in some way, so it will be considered an overhead for us 100%. So how do we avoid this? The same way we talked about dynamic memory allocation in C++, it is possible with something called unsigned character buffer. So once you define an unsigned character buffer, be it on heap or on stack, you can cast its elements to any type you want, as long as you have properly defined the size of your buffer. So your calculation, because as unsigned character is 1 byte, you have to make sure to have the size of your type and the size of your buffer and multiply those two. And each time you try to add or access the element or pop the element, you will need to proceed with your count and the size of the item type. So one second, I'm just looking at something here. So with that in mind, we've constructed our own implementation of this static storage that you can use, or I honestly suggest to implement this kind of thing on your own, as you are going to get a simplified version of something called aligned storage in C++. If we go to its usage on C++ reference, it is kind of, for lack of a better word, it's a lot to digest. Of course, you can get up to speed with it and whatnot, but still a little bit questionable. If you are someone who particularly is a fan of or tends to be practical and simplistic. So if your focus is simplicity and practice, maybe you can use your own static storage. If not, well, it is what it is. All right. So our usage of the static storage would be to first define it in our scope. And you may be wondering, well, I cannot do something like this. Well, you certainly can, but the problem with this is considered a global variable. So I suggest having an object like context that's a pointer at the global level context that you can use this across multiple files, but then we run into many other issues, which we are not going to get into this video. So the usage of our implementation, to get back to it, is that we add something to our storage, and I defined a macro for this reason. So if I am adding an item from my member function, I still have to perform the move. And then I end up with additional calling here. And we talked about this in the video called C++ memory allocation and C++ hacking destructors. Feel free to check it out if you're not sure what I'm talking about here. The point is to avoid the overhead of move and destructor. So, and even an implementation like Vector has this kind of thing where you cannot possibly avoid a move. So the only way you could avoid it is that if you implemented your own buffer and you define a macro like this, even though this macro is not 100% safe, because if we add an reference, let's say something like this, storage, add storage, and then I refer to it, we'll get an error. Because this item needs to be wrapped inside of an S. But that's an improvement I'll let you do and sort of brainstorm about it. So we effectively, to get back to the point, we effectively removed the additional move if we use a macro. Because now, and even though this function turns out to be inlined, it doesn't matter really. So I'll give you an example. So I'll enable O3 optimizations, and we still get a move. That just doesn't matter. O1, it doesn't matter. However, we achieved our objective here, and that is not to call unnecessary constructors and to fill the static buffer in C++ with unnecessary data beforehand, but C++ has to be able to make sure that everything is constructed first in order to call the destructor. That's why we have that handicap. But we are effectively removing that handicap with our own implementation of the static storage. And thus we get our desired performance boost. Thank you very much for watching, and I'll see you in another video. Take care.